So when you're doing the heparin protocol, you don't need to worry about, for the math part, you don't need to worry about filling these things in. So that's not the protocol. What the protocol is, or in order to answer the question, you're just answering these A, B, and C that we were just talking about just a moment ago. The A, B, and C is what you need to answer. Now, deciphering the protocol is a challenge in and of itself. So one of the things you need to know is what is important. So what is important is step 1 of the protocol, step 2 of the protocol, and step 10 of the protocol. So I know you can't see my step 10. There we go. Okay. So this is the steps 1, 2, and 10 tell you how to answer the questions on the back. Okay. And then we'll get to the 11 through 15 when we get to part C. So the first thing you need to know is what is the patient's weight in kilograms? So it is something that you need to do first. So you're going to convert the patient's weight to kilograms, which is, you're right, 50. Okay. So just put that in. Now you don't have to put it there. You just, I'm just putting it there as a placeholder so we remember. Then what we're going to do is we're going to go to the questions as they're stated. So question A says to calculate the number of milliliters to administer for the bolus. In the protocol, it says, well, the protocol is stated, so it starts here, but this is just a repeat of step 10 in the protocol. So just in case you encounter a question and that's not there, step 10 says the exact same thing as it does at the start of the question. So it says the bolus with 80 units per kilogram, and then to start a drip at 18 units per kilogram per hour. So what we're going to do is we're going to take that patient weight of 50 kilograms, doing A,
multiply by 80.
Yep, times 80.
Okay, cool.
And then we'll get 4,000 units.
Okay.
Now, we're not done because it says we need to calculate the number of milliliters, not units. So I need to find a way to convert the bolus units to bolus milliliters. And that's where you go to step 2 of the protocol. Step 2 says that we have 25,000 units in 250 milliliters, half normal saline. So that's your IV, and that's usually associated with your drop and flow rates. Okay. So that is not the bolus. The bolus is the bolus, and it tells you we have available 1,000 units per milliliter. So what you're going to do then is you're going to
4 milliliters.
You got it. Yep. You're going to convert the units to milliliters. You got it. Okay. The shortcut for this step A, because this will always be the same, you're just going to take the patient's weight in kilograms, multiply by 80, and divide by 1,000. If you do that every time, you will get A correct, or at least the initial bolus correct every time. The only thing that's going to change is the patient's
my
weight.
Kilograms.
Yep. Okay. Yep. But you're always going to take the patient's weight in kilograms times 80 divided by 1,000. In fact, anytime you calculate a bolus for heparin, in this heparin protocol scenario, it's going to be 1,000. So
okay.
So
that answers question A. Right.
And that answers the question for A.
Okay.
Do you need me to work through B as well?
Yes, please. Can you work through all of them with me?
Yeah, absolutely.
Okay.
All right. So, so that answered part A. Part B tells me to calculate the infusion rate in milliliters per hour. So again, we're talking about in steps A and B, it's not absolutely clear, but what we're assuming is that this is their initial entry into receiving heparin. And so We still have the same patient's weight. We go back to step 10, which tells us what to do when we start everything. And it says to start the drip at 18 units per kilogram per hour. So I'm going to take the patient's weight that we already calculated. This is for B. 50 kilograms times the 18 units kilogram hour. And then what we'll get is 900 units per hour. And again, we don't want units per hour. We want milliliters per hour. So that's when I go back to step 2 of the protocol and I look at my IV bag. Okay, so you can see I have 25,000 units, 250 ml, and that's what we're going to use to convert units to milliliters. 250, 25,000. And then what you'll get is, because you'll eliminate units, and that's where the 9 mil per hour comes in. Now the shorthand, you can also know, because this doesn't change, and this is the exact same protocol, you'll see the only difference is the patient's weight. That number is the same thing as 1/100. So the shorthand would be taking the patient's weight, and again, that will change. So in this instance, it's 50 times 18 divided by 100, and that will give you the answer for your flow rate. So someone asked me on Tuesday to what is the just basically the short skinny of this question, and that's why I am giving you these. These are shortcuts. So if you're practicing doing these and you just need a shortcut and you want to make sure you're getting the right answers, all you need to do is plug in the patient's weight and then times 18 divided by 100. That'll give you the answer to B. Patient's weight divided by 1,000. That'll give you the answer to A.
Okay.
Now C has 2 parts, part 1 and part 2. Oh, part 1. So give me 1 second. I'm going to close out my browser there. Okay. So part 1 is asking us, okay, we waited 6 hours. They were on this protocol for 6 hours where they received the initial bolus, and then they were on it for 9 milliliters per hour. So after 6 hours, we assess their APTT, and we find that the APTT is 43 seconds. So you can't see what I'm seeing. So the APT, so after 6 hours, APTT is 43 seconds. That's where we go to the back of the second part of the protocol, steps 11 through 15, and we look for the range that accounts for 43 seconds. And so that's step 12. So in this scenario, we need step 12. So that's another way that this question could be asked, is that this could be a different APTT, and then you would just follow based off of what range it falls into. So with the APTT of 43 seconds, we're supposed to rebolus with 40 units per kilogram and then to increase the rate by 2 units per kilogram per hour. So let's do that. So first of all, if my initial bolus was 80 units per kilogram and now we're doing 40 units per kilogram, it's just going to be half. So your answer is 2 milliliters. Before you even do anything, your answer is 2 milliliters. But just to work it out so you can see it, steps, patient's weight times what they told me, which is 40 units per kilogram. We get 2,000 units. We don't want units, we want milliliters. So I'm going to use that same bolus dosage strength that I used before, the 1 milliliter per 1,000 units. And then that's where we get our 2 milliliters. The shorthand for this, if you get where you have to follow step 12, again, patient's weight times 40 divided by 1,000. And that will give you the answer to C part 1. And then finally, C part 2. It says to recalculate the heparin drip. And for step 12, it says to increase the rate by 2 units per kilogram per hour. What was our initial rate based in kilograms per hour? Well, our initial rate was the 18 units per kilogram per hour. So if I'm increasing by 2, then that becomes 18, 19, 20, increased by 2. So I just want you to know where I'm going to get this number I'm going to put in here. So patient's weight times 20 then we get 1,000 units per hour. And then we're going to use the same step 2 IV to calculate the new flow rate in milliliters per hour. So that's the 250 ml over 25,000 units. And we get 10 mil per hour. And again, just for completing all the shorthand stuff, you take the patient's weight times 20 and divide that by 100. And you'll notice that every time I do a bolus-based question, I divide by 1,000. And every time I do a flow rate-based question, I'm dividing by 100. And that's consistent for all these heparin protocol type questions.
Okay.
So the challenge would be just to choose a different weight, you know, just pick a different weight and then just plug it in. And then I've been telling students, you can choose a different weight, plug it in. And then if you want to email me your answers, I will, I can just, what I'm going to do is just plug them into these things. And then I'll tell you that you're right or wrong. Just remember to round to the nearest 10th.
Okay, that doesn't seem too bad.
It's just the challenge is you've never seen it before.
Right.
And I know that. I know, and this is I've been doing this for over 10 years. And it's the same thing every, but then next semester, when you get into 4th semester, you have seen this. And it's because you'll see it again next semester. Okay.
Because I didn't do like any math. I was just.
Okay. So what I'm gonna show you is this will save you some time. Do the math.
Okay.
And all you have to do is you take the order. And I know what you were doing, and you were doing that right. But when you have a number that doesn't do that. Oh, so someone's asking for my email. If you were in the chat earlier, just copy and paste what I already sent out, please. Please just copy and paste into the messages for everybody. And my email address is at the end of what I posted earlier. Okay. So the order is 85. You have available the 50 milligrams per milliliter. Okay. Now, I always show doing dimensional analysis. If you like to do order over have or desired over have, you can.
Yes, I do.
Yeah, you can do that as well. Okay. So all I'm going to do is 85 divided by 50. Don't want to use my phone. And then you'll get 1.7. So that way you're not looking all over for your number, like, because what you were trying to do was rationalize or like use reason to solve that problem, which is perfect. And then you knew that your answer was somewhere on the timeline. So just give me 1 second. I'm gonna repost this since nobody was doing it. Oops, I just reposted the heparin protocol. Give me 1 second. try that again. There you go. Okay, so now, so you knew that was on there, and you knew that, okay, 1.5 was your 75, but then like, how do you find that out? That's where I think it's helpful just to go ahead and do the math. 85 divided by 50. So here's your 0.5, your 0.6, your 0.7. So you would just circle on the tube X, the 1.7 mil. Okay, so 13 tells us that we have dexamethasone, sodium phosphate, 5 milligrams intramuscular every 12 hours. Patient weighs 127 pounds. Strength is 4 milligrams per milliliter. So, and then it says how many milliliters to administer. So I'm actually going to set this up the same way I set up the previous question, where I'm going to take the order, which was 5 milligrams.
Right.
And then I'm going to convert milligrams to milliliters using the 4 milligrams per milliliter. 5 divided by 4 gives you 1.25 milliliters. And then you would round that to the nearest tenth to 1.3 milliliters.
Okay, so I just wasn't rounding.
Okay.
Because I got 1.25 and I just left it there. Okay.
Yeah. So you want to make sure you round to the nearest tenth on your problems on this. And the only time you do not round on this dosage calc test is when you're doing like the first 4 questions, when you're going from like milligrams to micrograms or milliliters to liters. Don't round those numbers. But but if you're going from pounds to kilograms, do round that to the nearest tenth, and then the rest of the test round to the nearest tenth.
Okay.